class, I'm back to continue 3.1, solving systems of equations. This is part B, where we're going to be solving the systems of equations algebraically. So we're going to talk about two methods. The first one is called substitution, and it is done by solving for one variable in terms of the other in one of the equations, then substituting that expression that you found into the other equation and simplifying. To solve using a system of equations by elimination, you add or subtract the equations to eliminate one of the variables. I prefer the elimination method, although when you take college algebra, you're going to have to be able to show both methods. So we'll go through both. I'm not going to spend time going through the example that's already provided. The first one is going to be, the first examples are going to be using substitution. So we'll just get right into it. We've got these three equations. And what you want to do is look at the equations and ask yourself, is there any variable that's just has a coefficient of 1? In this system, x right here just has a variable of 1. So it's real easy to get this by itself by rewriting this equation as x equals negative 2y plus 2. So all I did was take the 2y, move it to the other side of the equation, and make it a negative. Now I'm going to take this value for x, this negative 2y plus 2, and I'm going to substitute it into the first equation for y. So I will have 2x plus 3 times negative, whoops, I did it totally backwards, excuse me. I'm going to substitute this in for x, not for y, because x is equal to negative 2y plus 2. So I'll have 2 times negative 2y plus 2 plus 3y equals negative 3. I'm going to distribute through. 2 times negative 2y is negative 4y plus 2 times 2, which is 4, plus 3y equals negative 3. I can combine my y's, so I'll have a negative y plus 4 equals negative 3. I'm going to subtract 4 from both sides. That will leave me with negative y equals negative 7. So y equals 7. Now that I have this 7, I'm going to put it in to this equation where y is so I can find x. So I'm just going to go above it. I'm just going to draw an arrow up here. And I'm going to say that x is equal to negative 2 times 7 plus 2. That would be negative 14 plus 2, so x would be equal to negative 12. So my solution, written as an ordered pair, would be parenthesis negative 12, comma, 7, parenthesis. On the second system, I think I'll do the same thing. I think I'll get x by itself. So I'll rewrite the second equation as x equals y plus 9. I will substitute the y plus 9 in place of x in the first equation. So I will have 3 times y plus 9 plus 8y equals negative 6. I'm going to distribute through, so 3 times y would be 3y, plus 3 times 9 is 27, plus 8y equals negative 6. Combine my 3y and my 8y, so I'll have 11y plus 27 equals negative 6. Subtract 27 from both sides, so will give me 11y equals negative 33. Divide both sides by 11, and y will equal negative 3. Plug it in here, in place of y, so x will equal negative 3 plus 9, or x is 6. So my ordered pair will be parenthesis 6, comma, negative 3, parenthesis. And I know I'm going fast on these, so feel free to pause and rewind and watch again if need be. On the third third system, I think this time I'm going to get this y by itself. And in order to do that, I can rewrite the equation as y equals negative 2x plus 8. So I'm going to take and substitute negative 2x plus 8 in the second equation where y is 3x plus 3 halves times negative 2x plus 8 equals 12. 3x minus, because I'm seeing I'm multiplying 3 halves and a negative 2x, so that's going to be minus. The 2's will cancel, so I have minus 3x. Then I'm going to take 3 halves times 8, and that's going to give me the 8 divided by 2 would give me 4, 3 times 4 would give me 12. And notice if I clean this up, 3x minus 3x is 0, 0 plus 12 is 12. Well, 12 always equals 12, so the number of solutions on this one would be infinitely many. So INF many. We'll have an example of a no solution on the next 3 so that you can see what that looks like as well. Okay, so this is solving algebraically using substitution. Now we're going to use elimination to solve the system of equations, and the goal here is to get opposite coefficients for either x or y in order that they will cancel out and you can solve for the remaining variable. Then once you have it, you plug it back into one of your original equations to find the remaining variable. So let me move these up. All right, if you notice on the first equation here I have a k, and on the second equation I have a negative 3k. So I can take and multiply the whole top equation by 3. So I need to do it on both sides. Let's rewrite what we would have. We would have 6g plus 3k equals 15. Now I'll write the second equation underneath it. 3g minus 3k equals 3. Now we're ready to eliminate. 6g plus 3g is 9g. The 3k and the minus 3k cancel. 9g equals 18. So g would equal 2. Now it doesn't matter which equation we plug into. We've got these two original equations. I like to work with addition equations as opposed to subtraction if I can. So I'm going to take the first equation and I'm going to replace the g with 2. So I'll have 2 times 2 plus k equals 5. 4 plus k equals 5. Subtract 4 from both sides, k is 1. To write the ordered pair, write it alphabetically. So in other words, g comes before k, so let's write 2, comma 1. So parenthesis 2, comma 1. On this second system, notice I have, I could multiply by a negative 3 up here, and this would give me a negative 6q, as well as a positive 3r. So that's going to allow me to eliminate. This is going to be an example of no solution. So let me multiply the top equation by negative 3, and remember to do it on both sides. So I'll have negative 6q plus 3r equals negative 21. 6q minus 3r equals 14. Well, everything on the left zeroes out, so I'm just left with 0. On the right, I'm left with negative 21 plus 14, which is negative 7. See how that's not true? 0 is not equal to negative 7. So this is no solution. And then on the third system, since I already have opposite signs, why don't we multiply the top equation by 3, and I'm getting that 3 from right here, and the bottom equation by 2, I'm getting that 2 from right here. Then we'll have opposites for z. So the top equation by 3, the bottom equation by 2, 3 times 7 would be 21h, plus 3 times 2z would be 6z, equals 3 times negative 1, which is negative 3. 2 times 4h would be 8h, minus 2 times 3z would give me 6z, equals 2 times negative 13, which is negative 26. Okay, add 21 and 8 would be 29h. The z's canceled. Negative 3 minus 26 is negative 29. Divide both sides by 29. H will be negative 1. Okay, we can plug into either equation. Doesn't really matter. I think I'll just take in from the first equation. So I'm going to have 7 times negative 1 plus 2z equals negative 1. Negative 7 plus 2z equals negative 1. Add 7 to both sides. That will bring me over here to give me 2z equals 6. Divide both sides by 2. Z will equal 3. H comes before z, so when we write our solution, we'll write negative 1, comma, 3, and remember to enclose in parentheses. So that's just a few examples of each. I would encourage you to go back and look at the ones that were worked out for us also, for a little bit extra help. These aren't hard. They just take practice, and I know you'll do great. And I also hope you have a great day.